Okay, we're continuing with Unit 6, Day 2. We're multiplying monomials, and we're using the laws of exponents to do that. Let me see if I can get a little better feel with my size, maybe. Okay, so we are going to practice by simplifying each one of these expressions, and we are using our three laws of the exponents that we've been talking about. We've talked about the three laws that are product of powers. So if I have the same base and I'm multiplying things with the same base, I can add the powers. We have the power of a power. So if I have a base raised to a power and that whole expression is raised to another power, I can multiply exponents. If I have the power of a product, it means that I have things being multiplied inside parentheses, and all of that is being raised to a power, and so I can effectively distribute the outer exponent. So those are the three ideas that we're going to use when we solve these problems. Inside my parentheses, I have 4 times x squared times y. Everything in these parentheses is raised to the third power. So what I want to do is make sure that every single factor inside gets that power of 3. So I'm going to be distributing 2, 4, because 4 has an exponent of 1, right? It's 4 just to the power of 1. I'm going to distribute that outer 3 to the 2 in x squared, and I'm going to distribute this outer 3 to the invisible 1 exponent on that y. Here's what it looks like. It's going to be 4 to the 1 times 3 times x to the 2 times 3 times y to the 1 times 3. Just multiplying exponents right now. That leaves me with 4 to the third, x to the 6th, y to the third, and 4 to the third. 4 times 4 is 16, times 4 is 64. So all the way simplified, I'm 64, x to the 6th, y to the third. 64, that is. All right, so when I look at this next problem, I have more going on, so I need to pay attention to what else is going on here. I see that I have negative 3x squared times all of this raised to the power of 3. GEMDAS tells me that I have to take care of exponents before I can multiply. So I'm going to have to take care of that exponent first. That's the first section I have to do. I'm just going to bring down negative 3x squared. I'll multiply that times everything else after I've done the multiplication with my exponents over here. This 3 gets multiplied times the exponent for each of the factors. So I have 4 times x to the negative 2. This is 4 to the positive 1. So I'm going to distribute my 3 exponent to the exponent on my 4 and the exponent on my x. Okay, so I have 4 to the 1 times 3, that's 4 to the third, times x to the negative 2 times 3, so that's negative 6. Okay, I'm going to just kind of simplify this. I'm still going to take care of exponents that I can take care of, according to GEMDAS, okay? So I'm going to continue to bring down negative 3x squared. 4 times 4 is 16, times 4 again is 64, so this is times 64, x to the negative 6. And now I'm going to multiply negative 3 times 64. Negative 3 times 64 is negative 192. And then I have x squared times x to the negative 6. So remember, I keep my base and I add those exponents together. So I'm going to say 2 plus negative 6 as my new exponent. So this equals negative 192, x to the 2 minus 6 is negative 4. Do we like a negative exponent? Heck no, we do not. So we're going to move that guy to the basement so that he will stop being so negative. But negative 192 is happy. The number negative 192 is negative, but it is to the invisible power right there of positive 1. So negative 192 is happy. So our answer is negative 192 over x to the 4th. The only thing I had to fix was that negative exponent, okay? Make sure you feel comfortable with that. My number can be negative and it can stay right where it is. My exponent can't be negative. That's what I need to change. Okay, so over here, ab cubed times the quantity negative 2a cubed, all to the power of 2. Let's see what that works out as. ab cubed I'm just going to bring down because I don't get to use that yet. I'm going to distribute that 2 to everything inside my parentheses. Okay. Hold on 1 second, I've lost my cursor. So we need to be careful here because I am distributing this 2 to each of the factors in my parentheses. My factors in my parentheses, I'm going to rewrite this because I really want to make it clear. I have negative 2 times a to the third inside those parentheses. All of that is squared. So I need to distribute that squared to everything in here. I've got negative 2, and you can think of that as being inside parentheses. All right, it is because the negative 2 exists inside those parentheses and is being squared that I get to consider negative 2 to be in parentheses. So I'm going to be distributing this outer 2 to the power of 1 that I've got there, and I'm going to distribute that outer 2 to the power of 3 that I have right here. Okay, bring down ab cubed, and I have negative 2 to the 1 times 2. Negative 2 squared. Negative 2 in parentheses squared is positive 4 because it's negative 2 times negative 2. And then times a to the 3 times 2, so it's a to the 6. Okay, rewind and watch that again. Make sure you feel comfortable with the fact that I was able to consider negative 2 as the quantity that's getting squared here. Okay, so ab cubed times 4 times a to the 6th. I'm going to put my number first since we mathematicians like that number 4 in the front. I have a to the 1 times a to the 6. That's going to be a to the 1 plus 6, right? Same base. I get to add my exponents. Times b to the third. So I just kind of did some rearranging, and now here's my final answer. 4a to the 7, b to the third. That is my final answer. All right, as always, try the classwork on your own, and then you can maybe do one problem at a time if you want and come back and check, or you can do a couple problems and come back and check. But you definitely want to try it on your own first, because it is much easier to watch somebody else work through the problems and nod your head and say, yep, that works. And it's more challenging for you to do the work on your own. Okay, your instructions are to simplify each expression. Simplifying powers may require you to use multiple properties of exponents. That's what we had to do up here, right? Sometimes we were doing power of a power, sometimes we were doing power of a product. And sometimes we were doing, what was the third one? Product of powers, sorry. Okay, so just be careful of anything that actually has an invisible 1 as an exponent. Be careful of negatives and all that stuff. So pause the video, try some problems out, and come back and check and see how you did. Okay, so for number 1 here, I'm going to do the math that I can. 2 times 3, that's 6. And then I have x to the 4th times x to the 6th. I remember that I'm going to keep my base and add those exponents. So this answer is 6x to the 10th. Okay, next thing I'm going to do is look at problem 2. These are going vertically down. I don't suppose it really matters what order you do the problems, but I'm going to do problem 2 next. So I have 6a to the 5th times b all times that quantity, 2a to the 4th raised to the 5th power. This exponent on the 5 here, I have to take care of that first. So I'm just going to bring down 6a to the 5th b, and I'm going to distribute. Don't forget your invisible exponents. Be really careful here, okay? So I have 2 to the 5th. So I'm still multiplying times 2 to the 5th times a to the 4 times 5. I get to multiply. All right. 2 to the 5th, I believe, is 32. So I have 2 times 2 is 4, times 2 is 8, 16, 32. Yep. So I have, 6 times 32, I'm just putting my numbers first, times a to the 5th, times a to the 20th. So I'm going to say that's 5 plus 20 times b. All right, 6 times 2 is 12, 18, 19, that's 192, times a to the 25th, times b. And I don't really need that multiplication dot. I can rewrite that 192 a to the 25th b. Okay. Right. Let's see what we can do with number 3 here. And I do not have a calculator in front of me, so be paying close attention. And if you have a calculator, you can be watching me because this is a possible Jolly Rancher earning event. All right. I have the quantity 2m cubed, all to the 4th power. I have the quantity 8m to the 0. I have the quantity negative 6n to the negative 2. Okay, only one of these has an outer exponent, so this is the guy I'm going to start with. I need to distribute that outer 4 to every single factor inside. So this is going to be 2 to the 1 times 4, so it's 2 to the 4. Times m to the 3 times 4, that's m to the 12. I'm going to carry this over, times 8, m to the 0. This is 8 times m to the 0, but we know m to the 0 is 1. So 8 times 1 is just 8. Times negative 6n to the negative 2. I'm going to keep that as a negative 2 for now, but I might have to move that to the denominator if I don't get to add or subtract exponents to it. All right, 2 to the 4th is 16, so I have 16 times 8, I'm just rearranging, times m to the 12th. Oh shoot, I have also times negative 6. I'm going to pull negative 6 up front here too. Times negative 6. 2 to the 4th times 8 times negative 6. I've taken care of my numbers. And then I have m to the 12th and n to the negative 2. Now I am going to put n to the negative 2 in the basement right there. It becomes n to the positive 2 because I can see that I don't have any other n's to work with. All right, let's see if I can do this big math. I'm going to do 16 times 8 times negative 6 16s times 8 is 128, and then times negative 6. That's all going to equal this big number, negative 768 m to the 12th over n squared. If all went well, I didn't lose any negatives. I didn't forget about any of my exponents that were hanging out there being invisible, and I did my math right. Okay, let's move on. We're going to come on up here to number 4. Number 4, negative a to the 4th, b to the negative 2 times 4a to the 7, b to the negative 3. Okay, this really means negative 1 times all this stuff, right? And I have 4 times all that stuff. So I'm going to do my numbers first. This is negative 1. Negative 1 times 4 is negative 4. I'm going to work with my a's. I have a to the 4th times a to the 7. So I get to add 4 plus 7. So now I have a to the 11th. Now I'm going to work with my b's. I have b to the negative 2 and b to the negative 3. So I have negative 2 plus negative 3. That's negative 5. Okay with that? All right. That is almost my final answer, but of course I don't want a negative exponent, so I'm going to rewrite that. That's going to be negative 4, a to the 11. I'm going to say all over b to the 5th. But there are a couple of different ways that you can write that answer. Okay, we're getting through it. Number 5, here we go. X to the negative 2 times x to the negative 5 times y to the negative 1. And I have parentheses here, but it's all multiplication. So the associative property lets me rearrange those parentheses, right? I can also call this x to the negative 2 times x to the negative 5 times y to the negative 1. I can associate those guys first if I want to. It does not matter. I will. So that now I have x to the negative 2 plus negative 5, that's negative 7, times y to the negative 1. So that's all fine and dandy, except that I don't like negative exponents. So I'm going to pretend that that is over 1, and I'm going to move anybody who has a negative exponent down. Anybody who has a negative exponent is going to go down, and that leaves me with 1 in the numerator, because I'm actually multiplying and dividing stuff. So I'm left with 1 in the numerator. X to the negative 7 becomes x to the 7. Y to the negative 1 becomes y to the positive 1. So we'll just leave it as y. Okay, number 9, 2y all raised to the power of 0. Anything to the power of 0 is what? 1. So we're going to say that's just 1. That's gone. Now, I have to distribute this negative 2 outside the parentheses to all of the factors. How many factors do I have? I have 3 times x to the negative 3 times y to the negative 5. Don't forget about your happy little 3 in the front there. Let's distribute negative 2. 3 to the 1 times negative 2 becomes 3 to the negative 2 times x to the negative 3 times negative 2 becomes positive 6 times y to the negative 5 times negative 2 is positive 10. All right, so at this point, I only have one guy who is negative and needs a change of location, right? It's the negative exponent that I'm ever worried about. So this equals x to the 6th, y to the 10th, over 3 squared. 3 squared is 9. We're going to leave it like that. Okay, 2 more problems and then we are done. Always be careful when you are using the power rule and keep track of whether the part of the base that you are applying a power to is inside parentheses. Okay, just watch your negatives here. I have a to the 3rd times all of this, negative 3a squared to the 3rd. Okay, a to the 3rd times, I can think of this as negative 3 to the 3rd times a, so I'm distributing this 3, but it's going to the negative 3, right? Times a to the 2 times 3, a to the 6. Okay, so I end up with a to the 3rd times a to the 6th. That's going to be a to the 9th, because I get to add those together. All, oops, it's over 1. I don't know why I did that. Negative 3 times negative 3 is 9, times negative 3 is negative 27. So that's times negative 27. Mathematicians really prefer to write it like this, negative 27 first, and then a to the 9th. So that should be your final answer there. Okay, let's take a look at our very last problem. Oh no, we might have more than this. Let's see. I have negative 2x to the 4th, y to the 3rd, all times negative 4x squared, y to the 4th, raised to the power of 2. I need to take care of this part first because I have an exponent. GEMDAS makes me do exponents first. So I'm just going to bring down that first part and not do anything to it yet. Negative 2x to the 4th, y to the 3rd, times, let's get this 2 distributed. 2 goes to that negative 4, 2 goes to the x squared, 2 goes to the y to the 4th. Negative 4 to the power of 2. I'm going to write it out in parentheses just to show you that's what's happening. It is negative 4 to the power of 2 times x to the 2 times 2, so that's 4, times y to the 4 times 2, that's 8. Okay, that's that whole bunch of stuff. Now it doesn't really matter that I've got these parentheses because every single term is being multiplied. So I'm going to do my numbers first. Okay, I'm going to pull my numbers. Negative 2 times negative 4 squared is negative 4 times negative 4, so it's positive 16. Any other numbers? Nope. Okay, now I'm going to do my x's. I have x to the 4 plus 4. I have x to the 8. And now I'm going to do the y's. I have y to the 3 plus 8, so I have y to the 11. Negative 2 times 16 I can do. That's negative 32. X to the 8th, y to the 11th, and that is my answer. Okay, so I thought we were at the end there. Just kidding though. We have one whole page left. Continue to try these on your own and then, pause the video and come back and see how you did, okay? We're going to simplify each expression using the product rule. So that means if we are multiplying two things that have the same base, we just add the exponents. Okay? We want to write final answers in scientific notation, and I will tell you, having worked in the science field, we really do like to have an answer like 3.2 times 10 to the 4th, something like that. We like to use the x when we're talking about scientific notation, so I personally want that to be an x instead of a dot. It's just scientific notation. We prefer that x. And I forgot to change that from last year on this video, on this worksheet. Okay, so I have 4 times 10 to the 3rd times 4 times, I'm sorry, I can't even read my own numbers, 4 times 10 to the 3rd times 2 times 10 to the 5th. So here's what I'm going to do. I can multiply just the plain numbers. Let's look at this a different way first. If I had 4 times m to the 3rd times 2 times m to the 5th. Say, pretend this is what my problem is. 4 times m to the 3rd times 2 times m to the 5th. I can multiply 4 times 2, right? I know how to do that. That's 8. And then with my product rule, m to the 3rd times m to the 5th is going to be m to the 3 plus 5. It's going to equal 8 times m to the 8, right? That is what we are doing here, but instead of m to the 3rd, I actually have 10 to the 3rd. So this is what we're doing. 10 is my base that's the same. So I'm going to use the base 10, and I get to add those exponents. Okay, I can multiply 4 times 2, and I get 8. Times 10 to the 3 plus 5, 10 to the 8. I want to double check that my coefficient here, or my factor, is between 1 and 10. Remember, 1 has to be less than or equal to a, which is less than 10, when a is that factor. Okay, let's see if we can try this on number 10. Okay, 1 times 10 to the negative 8 times 6 times 10 to the 3rd. My base that's common is a base of 10. Okay, so that's the thing. I'm going to keep that base and add those exponents. I can multiply 1 times 6, and I get 6 times 10 to the negative 8 plus 3 is going to be negative 5. Double check and make sure that first factor is in between 1 and 10, and it is. So that looks pretty good, like it's in scientific notation the way it is supposed to be. All right. Different teachers are going to have different opinions on the dot for multiplication. So I suppose technically this is the same information, but I'm just telling you from personal experience. People prefer that x to multiply when you're talking about scientific notation. All right, here we are. We have 11 and 12, so we're still working on scientific notation. It says first express each number in scientific notation. So first we're going to do that, and then we're going to simplify using the laws of exponents. Okay, and then we want to make sure, like I said, make sure that final answer is in scientific notation. All right, so if I'm first going to express this in scientific notation, then 0.3, I have to change that. Remember, to change that scientific notation, 0.3 written in scientific notation, I have to move that decimal over, and I'm going to have 3 times 10 to the something, right? I moved it over 1, but it was 0.3. It's a pretty small number. So we're going to say that that is 3 times 10 to the negative 1. If I want to write 300,000 in scientific notation, I want my decimal right there. Remember this. Okay, and so it's going to be 3.0, or 3 times 10 to the, my decimal originally was here, and I went 1, 2, 3, 4, 5. I moved it 5 spaces, and 300,000 is a pretty big number, so we're going to say 3 times 10 to the 5th. Those are the two factors that I have, but now they're written in scientific notation. So I'm going to rewrite that. 3 times 10 to the negative 1 times 3 times 10 to the 5th. Okay, so first, express each number in scientific notation. Check. Second, we're going to multiply. So I can multiply 3 times 3. You know 3 times 3 is 9, but if we want to keep the base and add the exponents, watch this. We keep our base of 3, and our exponents were 1 plus 1. It's 3 squared. Okay, I know you know 3 times 3 is 9, but just to show you that this method works. Okay, it's times 10 to the, I'm going to add -1 and 5, and I'm going to get 4. And then I'm going to rewrite that. It's 9 times 10 to the 4. And am I happy with that? Is my 9 good? Is this in scientific notation? It is. Okay. Over here, 0.004. Let's get back to some scratch paper. 0.004 in scientific notation needs to be 4 point something, right? So I have to move that decimal, whoomp, whoomp, whoomp. I had to move it 3. So it's 4 times 10 to the 3, but remember, that's a really small number, yeah? It's less than 1. It's in between 0 and 1, it's positive, it's less than 1, but we're going to say that that's -3 because it's just very small. Okay, now I have 0.5 that I need to write in scientific notation, so whoomp, move that guy over. It's going to be 5 times 10 to the -1. Okay, those are my two numbers in scientific notation, so let's put them up here. I have 4 times 10 to the -3 times 5 times 10 to the -1. And now I get to use my, my product rules, my laws of exponents. 4 times 5. It's not the same base, so I don't get to use that little trick, but 4 times 5 we can do 20. Times 10 to the -3 plus -1 is -4. This is not in scientific notation, though. Hold on, not scientific notation, because 20 doesn't fit the bill, right? 20 is not in between 1 and 10. Then I have to rearrange. I have to just deal with that. I want it to be 2.0, okay? So instead of 20, I want it to be 2.0. So I'm going to move that decimal over 1 time, okay? And it is a big number, so I'm going to move it over by +1. Right, so I now have 2 times 10 to the +1, and -4 is -3. If that was a little bit, if you're wishy-washy on whether you're adding one or subtracting one or whatever, what you can do to rearrange is you can say 20 times 10 to the -4. You can put that in standard form if you want. That's 20. That's where my decimal is. I can go 1, 2, 3, 4. Okay, so 20 times 10 to the -4 equals 0.0020. If I now want to put that in scientific notation, this is where I want my decimal, right? So I have 0.0020. I want to put it in scientific notation. So I'm going to have 2 times 10 to the, I'm going to go 1, 2, 3. It is a really small number, so it's going to show up as a negative, but I'm going to say 2 times 10 to the -3. And that's what we decided on earlier. I personally would probably write it out in expanded form and then put it back into scientific notation because I get nervous about whether I'm adding or subtracting those exponents. But it's up to you. Okay. Geometric applications. We all love our geometry, and we know that perimeter equals 2 times the length plus 2 times the width of any rectangle, and we know area equals length times width. So I need to find the perimeter and the area of this guy. It doesn't matter which one I call length and which one I call width. I'm just picking one, okay? So if I want the perimeter, that equals 2 times the length, so it's 2 times 12x, plus 2 times the width, so it's 2 times 5x squared. Okay, I'm going to do any math that I can do. 2 times 12 is 24 times x, plus 2 times 5 is 10 times x squared. That's my perimeter. If I want to be super fabulously technical, I'm going to write it with my 10x squared first, plus 24x. That's the same, that's just in descending order. So that's my perimeter. That's one answer. If I need the area, it's length times width. So the area is length times width. So it's going to be 12x times 5x squared. So I'm going to multiply numbers together because I can do that. I have 60. And then x to the 1 times x squared. I keep my base, and I add 1 plus 2, I have x cubed. So my area is 60x cubed. Okay, we have one more. Remember, you're checking these on your own. Sorry, I was just double checking my old key to make sure I didn't make a mistake there. I did just fine, yay me. You find the perimeter and area here. So perimeter of a triangle is going to be side 1 plus side 2 plus side 3, right? I just get to add all the sides together. Area of a triangle is 1/2 times base times height. Okay, so base and height, they just have to be on the perpendicular sides. Base and height have to be on the perpendicular side. So I'm going to say that this is the base. I'm going to say that this is the height. Okay, so my perimeter, I'm just going to add all the sides together. My perimeter is 4a squared b plus 3ab plus 10a squared b. I just picked all three sides and I'm adding them together, and now I'm going to combine like terms. To combine like terms, I have to make sure I have exactly the same variables with exactly the same exponents. I can combine 4a squared b and 10a squared b. Those are like terms. I had 4 of them, and now I have 10 more of them, so I have 14a squared b's plus 3ab. There's nothing else to do with that information, so that whole big expression gives me my perimeter. My area is 1/2 times the base. Now I suppose I should have said that's base and maybe that's height. That kind of makes more sense visually, doesn't it? Doesn't matter because I could rotate that, couldn't I? Okay, my base, we're going to say it's 3ab, and my height, we're going to say is 4a squared b. Okay, so I'm going to multiply my numbers together. 1/2 times 3 times 4. I'm going to go out of order because I know half of 4 is 2. So 2 times 3 is 6. I know 1/2 times 3 times 4 is 6. A times a squared is going to be a to the 1 plus 2. That's going to be a to the third. Times b to the invisible 1 plus invisible 1. It's now b squared. So my area equals 6a cubed b squared. All right. Thanks for watching.